Today we will discuss about prepare a presentation of working compiler by characterizing it into different phases. Let's start. Introduction. A compiler is a special program that processes statements written in a particular programming language and turned into machine language or a code that a computer processor uses. Typically, a programmer writes language statement in a language such as Pascal or C one line at a time using an editor. The file that is created contains what are called the source statements. The programmer then runs the appropriate language compiler specifying the name of the file that contains the source statement. When executing, the compiler first parses all of the language statements synthetically, one after the other, and then in one or more successive stages or phases, builds the output code, making sure that statement that refers to other statements are referred to correctly in the final code. Additionally, the output of the compilation has been called object code or sometimes an object or module. Note that the term object here is not related to object-oriented programming. The object code is machine code that the processor can execute one instruction at a time. Second, syntax analysis. Recover the structure described by using a series of tokens from the previous scanner. The next phase is called the syntax analysis or parsing. It takes the token produced by lexical analysis as input and generates a parse tree or syntax tree. In this phase, token arrangements are checked against the source code grammar. That is, the parser checks if the expression made by the tokens is synthetically correct. Fourth, IR generation. After semantic analysis, the compiler generates an intermediate code of the source code for the target machine. It represents a program for some abstract machine. It is in between the high level language and the machine language. This intermediate code should be generated in such a way that it makes it easier to be translated into the target machine code. 6. Code generation. In this phase, the code generator takes the optimized representation of the intermediate code and maps it to the large target machine language. The code generator translates the intermediate code into a sequence of relocatable machine code. Sequence of instruction of machine code performs the task as the intermediate code will do. 7. Optimization. The next phase does code or optimization of the intermediate code. The optimization can be assumed as something that removes unnecessary code lines and arranges the sequence of statements in order to speed up the program execution without wasting resource CPU memory. Our next topic is phases of compiler. There are two main categories of compilation: front end, back end. Analysis: machine independent and language dependent. First, this is the first front end of a compiler where an intermediate representation of the source code is created. Second, Data from the source program is collected and saved to a data structure called a symbol table. Third, analysis can be fourth, linear scanning where a stream of characters is read from left to right and grouped into tokens with a meaning. Fifth, hierarchical tokens. Hierarchical tokens are characterizing hierarchically into nested groups. Semantic evaluation the meaning of the components of a source program. 7. Analysis comprises of lexical analysis, syntax analysis, semantic analysis, and intermediate code generation, which we discuss below. First point is lexical analysis. This is the first phase in the compiler. Source code is scanned from left to right, character by characters, and grouped into tokens. Character stream is grouped into meaningful sequences by the identified tokens. Lexical analyzer is also referred to as a scanner. Functions identifies and identification of illegal tokens. Identification of lexical units, example in source code. Classification of lexical units, example constants, keywords into different tables. It ignores command. Second point is syntax analysis. Converts the stream of token into parse tree. Syntax analyzer can also be referred to as the parser. All tokens are checked against the grammar of the source code to ensure correctness. Functions report syntax errors, construction of a parser, obtaining tokens from the lexical analyzer, checking for syntax errors. Third point is semantic analysis. A semantic analyzer determines the validity of the parse tree. An annotated syntax tree is the output from the functions. Type checking if source language permits provided operands or not. Collection of type information, saving gathered information to symbol table or syntax tree. Report semantic errors, checking for semantic errors. 4 point is intermediate code generation. Now the parser is semantically verified. An intermediate code generator generates the 3 address code. Assembly like instruction with 3 operands or instruction. Each operand acts like a register. The code is intermediate, that is, it is neither high level or machine code. This intermediate code will later be translated to machine code. This phase acts as a bridge from analysis or to synthesis. Functions maintaining precedence ordering of the source language. Translation of intermediate code into target language. Holding values are computed during the translation process. Holding operands of an instruction. Next point is synthesis, machine dependent and language independent. This is the back end of a compiler where an equivalent target program is created from the intermediate source code. Synthesis constitutes of the code optimizer and code generator, which we discuss below. Fifth, a code optimizer. It reduces the size of the program by reducing the number and unnecessary of lines of code in the address mode code so that the program takes the least amount of memory and exhibits a fast execution time. This improves performance. Functions removal of unused variables and unreachable code, improving runtime and performance of program, establishing trade-offs between execution and compilation speed, generates streamlined code from its intermediate representation, removal of unaltered statements from a loop. 6. Code generator. In this phase, assembly code is generated from the optimized code. For each variable used by the program, a memory location is allocated. Functions converting intermediate code to target code. Selection and allocation of memory allocation and registers. Symbol table. This is the compiler data structure that stores identifiers with their name and types, therefore enabling easier search and retrieval. It interconnects with the handler and all phases of the compiler for updates. It is responsible for scope management. It stores literal constants and strings. Compiler generated temporaries, function names, variable names and constants, label in source language, function in various phases of the compiler, lexical analysis, creation of a new table, syntax analysis at information regarding type scope, etc. Semantic analysis uses already stored information to check semantics and update accordingly. Intermediate code generation, reference for runtime allocation and storage of temporary variable information. Error handling downtime. This downtime is responsible for detecting an error, reporting it, and implement a recovery strategy for handling the error. Common errors that happens are invalid character sequence during scanning, invalid text token sequences, scope error, parsing is semantic analysis. Some of the errors that can happen during these phases are lexical analyzer, wrong spelling of tokens, syntax analyzer, missing parentheses, intermediate code generator, mismatch of operands for an operator, code optimization, unreachable statements, code generator improper allocation of registers or fully memory, symbol multiple declared and identifier.